Hello, my people. All right, this video we're going to go over three problems that are asked in pretty much the way that a free response question on the AP exam will be. It'll give you a scenario and then ask you, 3 or 4 questions based upon that scenario. So let's go ahead and let's jump right in. Now, it says the position of a particle at any time t is greater than or equal to 0 is given by the following parametrics, right? And it says find the magnitude of the velocity vector at time t is equal to 4. Well, if we're going to find the velocity vector, the magnitude of the velocity vector, stands to reason that we need to actually find the velocity vector first. So let's rewrite these parametrics in terms of a vector value function. Now, if I want the velocity, I need to basically take the derivative component by component, which basically gives me 2t and 2t squared. Now that means that my velocity vector at 4 is the vector 8, 32. And if I want the magnitude of that, it basically means the length, right? And usually that's either double bars or single bars. I like the double bars. And it's asking for the length of it, which is of course just the distance formula or Pythagorean theorem. And so it will be 8 squared plus 32 squared. And you can plug that into your calculator and get 32.985. Okay. Now the second thing that it asks is for the total distance traveled by the particle from t is equal to 0 to t is equal to 4. Now, if we're looking for the total distance, okay, we're going to take the components from our velocity vector right here. And we're going to use those as our dx dt and our dy dt and plop them into our arc length formula. We know it as arc length when we're dealing with parametrics. We know it as total distance when we're dealing with vectors, but it's really the same thing. And basically this one, you can do it by hand. This one is actually doable by hand because it becomes 0 to 4, and this becomes 4t squared plus 4t to the 4th. And then basically when you pull out that 4t squared, you're going to get 2t 1 plus t squared. And I think you can pretty much see the fact that that's going to be a simple u-sub problem. But basically, if you plug it into your calculator, you would go ahead and get 46.062. But this one you actually could do by hand. And if you want to do it at your leisure, go ahead. Now the last part says find dy dx as a function of x. Now, we've already found the vectors for dx, I've already found the vector for velocity, which means that, in essence, we found dx dt and dy dt. So if I want dy dx, I simply need dy dt over dx dt, and that's going to be 2t squared over 2t, or just t. But they did say as a function of x. So, you could kind of come over here and say, well, x, as we know, is t squared minus 3, and therefore t squared is equal to x plus 3, or t is equal to the square root of x plus 3. And so my dy dx is equal to x plus 3. And you simply would have to make the caveat, obviously, x is going to be greater than or equal to negative 3. But that is basically what's going on right there. Now, you could, of course, you could have originally gone in and instead of solving this here and plugging it in right here, you could have eliminated the parameter in the original, gotten your y in terms of x, and just differentiated like that. But that's and you can do it at your leisure. All right, let's go ahead and move on to the next one. This one is actually going to take a bit more paper. This is a particle moving along a curve. Let me zoom in a little bit because the type is a little bit smaller. A particle moving along a curve in the xy plane has position x of t, y of t at time t with, and of course this is, you can do it like this in terms of parametric, or you can recognize the fact that these are your components of your velocity vector. At time t is equal to 3, the particle is at 1, 4. So basically this means your velocity vector is sine of t cubed minus t and cosine of t cubed minus t. And your and it says at time t equals to 3, the particle is at the point, so you would do the r. I'm trying as much as I can to make my r's not look like my t's. R of 3 is equal to the vector 1, 4. Alrighty. Well, let's go ahead and let's ask, well, now that we've sort of turned what we had up here into, component form, let's go ahead and look at part A. It says find the acceleration vector for the particle at time t is equal to 3. Well, first we need to go ahead and differentiate v in order to get our acceleration vector in terms of t. And of course we're going to have to use the chain rule. So we have 3t squared minus 1 times cosine of t cubed minus t. And we have 3t squared minus 1, and we have negative sine of t cubed minus t. And that is big and nasty and long, and I don't like it, but if we plug in 3, it's actually not that bad. Plug in 3 into here, you're going to get 27 minus 1, or 26. Plug into here, you're going to get 27 minus 3, or 24. So it's 26 cosine of 24. And this one's going to be negative 26 sine of 24. Now, we don't usually like, having angle measurement expressions that are radians, but not in terms of pi, and especially not unit circle values. But you can plug this into your calculator and get a decimal approximation. And what happens is it's 11.029 and 23.545. And that is your answer to part A. Now let's go ahead and find B. It says find the equation of the tangent line to the curve at the point where t is equal to 3. Now, that's a little bit complicated because obviously you can find your dy dx just by using these right here, right? Your dy dx is going to be easy to find. The problem is you need to also find the initial position, because you have at time t is equal to 3, the particle is at 1, 4, but you need to backtrack to time t is equal to, actually, no, you don't, because it's t is equal to 3. Never mind. I could have sworn that said t is equal to 0 right there, but let's go ahead. So we have a point, and now all we need is slope, right? Because you need two things for the equation of a tangent line. We need point and slope. Well, my dy dx is going to be cosine of t cubed minus t over sine of t cubed minus t, which is of course going to be cotangent of t cubed minus t. And if I'm going to evaluate that at time t is equal to 3, then what I'm going to get is I'm going to get cotangent of 24. Now, cotangent of 24, you don't have a cotangent on your calculator, but you can go ahead and do, tangent of 24, and then simply reciprocalize it, and you're going to get negative 0.468. So this gives me negative 0.468. Now, if you don't want to deal with decimals, you can actually just put it in that form right there. It doesn't really matter to me, but you already have your ordered pair of 1, 4 at t is equal to 3. So it's basically y minus y1 is equal to either cotangent 24 or negative 0.468 x minus 1. And there is the equation of your tangent line. Yay! Now, what it asks next is for the magnitude of the velocity vector at time t is equal to 3. Well, first of all, if we're going to do that, we need to find the numerical velocity vector at time t is equal to 3. So let's go ahead and find that. Now, basically that means that I'm going to have sine of 24, cosine of 24, sine of 24, cosine of 24, and that works out to approximately negative 0.906 and 0.424. But the thing is that you don't really need these, because if you're trying to find that, it's probably easier to plug it in just as sine of 24 squared plus cosine of 24 squared. And lo and behold, it's 1. Because sine squared of anything plus cosine squared of that same thing is going to be 1, and the square root of 1 is 1. There you go. Fun, fun. All right, let's go ahead and do the last portion of this, where it asks us to find the position of the particle at time t is equal to 2. So, position at time t is equal to 2. Well, what I need in order to do that is I need the position at t is equal to 3, which I have, minus the displacement, okay, from 2 to 3. Okay, so let's go ahead and let's find our displacement vector. Our displacement vector is going to be 2 to 3 of sine t cubed minus t dt, and 2 to 3 of cosine t cubed minus t dt. Now, you're obviously going to need to use your calculator to get an approximation of this, and then we simply remember that position at time t is equal to 3 is what? It's 1/4. Okay, so this implies 1/4. So really what you're doing is 1 minus this integral, comma, 4 minus this integral, right? And it's minus because you're sort of backtracking, right? If you're looking, if this is position at time t is equal to 3, I need to subtract the displacement. If I was given t is equal to 2, if I was given t is equal to 2 and asked for t is equal to 3, it would be plus, right? And so this right here, you wind up with, and let's go ahead and quit that and go back to the main screen. Okay, let's do sine of t cubed minus t, and then cosine of t cubed minus t. And if I go back to the main screen, I can, sorry, I need to go, okay, I need to get the integral from 2 to 3 of x1 dt. Now, what I could have done to make it a little bit easier is I could have gone back here and inserted 1 minus. Okay, and that actually would have helped me out a whole lot. And I get 0.932. And then the next one, I can do 4 minus the integral from 2 to 3 of y1. And that should be my order pair. My order pair should, or my, not my vector, my order pair should be 0.932 and 4.002. And so it actually didn't travel very far from 1/4, did it? Alrighty, let's look at one more before we adjourn and call it quits. Alrighty. At time t greater than or equal to 0, a particle is moving along the curve in the xy plane, has position, x of t and y of t, with velocity vector, and they give you the velocity vector. At time t is equal to 1, the particle is at 3, 5. Now, find the x-coordinate of the position of the particle at time t is equal to 2. Well, that actually is really, really easy, right? Because, you just did twice that work in the last part of the previous problem. All it's asking for here is not the whole order pair, but just the x-coordinate. So really, it's where it started off at in terms of the interval that you're looking at. So, 3 plus the displacement from 1 to 2 of cosine t squared dt. Okay, well, you can go ahead and plug that into your calculator. It winds up being 2.557. I'm not so much worried about you being able to punch buttons in your calculator, but I need you to understand kind of what this means. This is basically the x-coordinate at t is equal to 1, and to get the x-coordinate at t is equal to 2, you simply need to start with where it is at t is equal to 1, and then figure out how much it's moved between 1 and 2. Now, for part B, it says, for t between 0 and 1, there is a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? Okay, so what I'm really looking for is I'm looking for where the slope is 2. And by slope, they mean dy dx is equal to 2 at what t? Well, let's go ahead and let's dy dx. This is the velocity function, so this is dy dt and dx dt. So dy dx is simply e to the 0.5 t over cosine t squared. And you're basically asking, when is that equal to 2? Well, you're not going to be able to do that really easily, except by means of your calculator. And so what we're going to do is, let's just go ahead and ask it like it's asking a function. When is this as a function, which you can plug into your calculator as e to the x divided by 2, right? Because that's 1/2 t. And since I put it back in function form, this is x over 2. And then cosine of x squared. And I'm simply going to also put into y2, 2. Because where those intersect, we're going to have our value of t. Now, if we go to the window, remember it's specified between 0 and 1. So let's go 0 to 1, and let's go ahead and let's graph. And here comes the curve, which is basically, like I said, I plugged in for y1, e to the x over 2, and then cos over cosine x squared, and then in for y2, I plugged in 2. Now notice they intersect, and I basically specified the window from 0 to 1. So remember, you can go up here and press second trace, which is for calculating, 5, and you just kind of scroll over close to where it is, right? And you press enter, and then it pops up to the other one, and you press enter, and it says, hey, are you close enough to that point of intersection? You think that's a good guess? And you say, yes, it is. And then it gives me the value 0.840. Okay? So t is approximately 0.840. Okay. Now, let's go on to part C. And of course, C is also going to be a calculator one, because it asks, find the time at which the speed of the particle is 3. Okay? The speed of the particle is, of course, the magnitude of the velocity vector. So if you're looking for the speed is equal to the magnitude of the velocity vector. And I'm actually looking for the speed at 3. Okay? So if I'm looking for it at 3, basically what I need, no, it's not, okay. Find the time, it's find the time when the, okay. So what I'm looking for, this is not an input-based question, right? This is an output-based question. It's asking when is the speed 3? So it's not the magnitude of the velocity vector at 3, it's the magnitude of a velocity vector is 3. Okay, well that means that I simply need to find the velocity, the expression for the magnitude of the velocity, which is of course e to the t, because when you square e to 1/2 t, you basically multiply it by 2 and it becomes e to the t. And then of course you're going to square the cosine as well. Well, that again is going to be problematic in terms of determining a value. So we're again going to use our calculator. Okay. So what I need to do is I need to basically put this in as e to the x plus cosine of x squared, and then square that as well. And I need to know when that's equal to 3. Okay. And I need to change the window because it's not going to be between 0 and 1, but it is going to be between 0 and 3. And here comes, again, so basically into y1, I put the square root of e to the x plus cosine squared x squared. And then into y2, I put 3. And I'm going to do exactly the same thing I did last time. I'm going to calculate the point of intersection. Go close to it, press enter, and what I get is t is approximately 2.196. Okay, now this particular problem has been a lot of calculator work. Now this last one asks for the total distance. Find the total distance traveled by the particle from time t is equal to 1 to time t is equal to 0 to time t is equal to 1. And that's 0 to 1. Now, of course, it's going to be this same radical right here, right? E to the t plus cosine squared t squared. Now, it's already in your calculator, so you could actually go back to the main screen and use your y1. And basically what you're going to get is 1.595. Okay, now obviously that one was calculator heavy. I hope that all makes sense to you. I hope that it is helpful in terms of sort of fleshing out the application of both differential and integral calculus to vector value functions. When I see you after the break, we'll sort of clean up anything that needs cleaning up. But I hope you have a wonderful Thanksgiving, and I will see you afterwards. Bye.